So this related rates question says that an escaped prisoner is directly beneath a spotlight 10 meters above the ground. If he runs away at 5 meters per second, how fast is the tip of his shadow, so the tip of his shadow moving when he is 8 meters from his starting position? And then note that the prisoner is 2 meters tall. Okay, well, let's start again with what we know here. And we'll zoom in a little bit here. So what we know is, to begin with, this prisoner's right here. Okay, here's the spotlight, and it's 10 meters up. And then the prisoner starts to run away. So your prisoner at some point is going to be out here. And we want to know how fast the tip of the shadow is moving. So we're looking for this little guy right here. How fast that little mark right there is moving. Now, that mark right there, how fast that's moving, that is actually going to be how fast the distance here is changing, the whole line segment here. So if we throw in some variables here, maybe what we'll do is we'll call this Z. Typically, I would call the distance that the prisoner is away from that light post here X, because that's how we're measuring his speed. Okay, is how fast this distance is changing. How fast the tip of his shadow is moving is this guy right here. Now, we're talking about his shadow. This right here is the length of his shadow. Now, I'm bringing this up here because I'm not going to have a lot of information about these triangles. I do know that this prisoner here is 2 meters tall. Okay, I do know that he's moving at 5 meters per second. So we know that dx by dt, okay, because he's running, and this is the distance this distance x here is how far he is from that spotlight, okay, really horizontally here. So how fast that distance moves here, this x distance increases, that's how fast he's moving. So I know that this is 5 meters per second. Now, I don't know anything about the hypotenuses here, okay? So what I've got here, if I kind of break this down in terms of just strictly speaking what I know, I've got these two triangles, okay, that I've formed, where this is 10, this is 2. The large triangle here, I know I've labeled this distance here Z, and I know that this distance here is Y. Okay, at least that's how I've labeled it over here. Now, what I do know about those triangles, they're both right angle triangles, okay? I do know that they're going to be similar, meaning that that ratio here, 10 over Z, okay, height to length here, is going to be the same for the big triangle as it is for the little triangle, 2 over Y here. Okay, so I know that this is going to be true. Now, let's identify what is it that I want. Well, what I want is dz by dt. dz by dt is representing that distance right there, and as that one changes, that's how fast the tip of his shadow is moving. If I wanted to know how fast his shadow itself was growing, that would be dy by dt. But that's not what this question is asking for. So now I'm going to take this ratio right here, this proportion, I'm going to set this one up here. So now I know 10 over z is going to equal 2 over y. Okay, that's awesome, but not entirely useful to me right now because I don't know anything about y. I'm looking for dz by dt, so I'm glad that the z is in this proportion here, but I don't actually know anything about y. Let's go back up to here. Okay, well, I do know something about x. I would like something about x in there. Y, okay, well, look at this. Y is just going to be z minus x. So I can actually replace that right now, make this 10 over z is going to be equal to 2 over z minus x. Okay, now I've got the variables in there that I'm interested in. I know I'm looking for dz by dt, so I've got z there, and I know what dx by dt is. Good, so I've got the variables I need here. So now I'm just going to multiply across here. So 10 times z minus x will equal 2 times z. We'll distribute that out. 10z minus 10x equals 2z. You know what, I'd be tempted to bring that 10x over, bring the 2z over, so that'll be 8z is equal to 10x. Now, I don't know, those are both, I can simplify this. It's not really all that necessary because I can either do it now or later, but they're both divisible by 2. So maybe 4z is equal to 5x. And now take the derivative. Or actually even divide by that 4 first. So z is equal to 5/4 x. So now dz by dt will equal 5/4 dx by dt. We take the derivative implicitly with respect to time. Okay, this is a related rate. Now I'll do my substitution. But before I do that, notice I was told something in the problem. I was told, I was told that he was 8 meters away from that directly below that spotlight there. That 8 meters was a value of x. But notice that x by itself as a variable doesn't actually show up in the derivative, which means that it's actually not that important. That little bit of information is kind of a red herring. It doesn't actually give you any information that you need to solve this problem. All I really need here is how fast x is changing, and I know that that's going to be 5. And so this is going to end up being 25/4. What have we got here? Meters per second. And actually, it probably makes sense because I've done this with many others. Just to get the decimal version of this, this means this is going to be 6.25 meters per second. That probably gives you a better visual as to how fast that tip is moving.